Welcome to Shivaji channel. Now in this class I am explaining about the topic is straight line. This is very used in your Eamcet exams. So first of all, you have to know what is the concept. What are the various concept content on these straight lines? In this straight lines has the general equation of the straight line is ax plus by plus c is equals to 0. This is the general equation of the straight line. First I am explaining about the slope. Slope is denoted by small m. Here suppose this ax plus by plus c is equals to 0 line. This is x-axis and this is y-axis. This line makes an angle theta with the positive direction of x-axis. Then this theta is called inclination of the line. Here theta is called what? Inclination of the line. Here slope is denoted by small m. This slope m is equals to tan theta. If theta is given, in this case, the slope of the line is m is equals to tan theta. Suppose 2 points are given. Suppose A, B are the given 2 points on the straight line. Here also this line makes an angle theta with the positive direction of x-axis. But here A, B, these 2 points are given. In this case, how can you find the slope? Let us see. In this case, the slope of the line small m is equals to y2 minus y1 by x2 minus x1. Okay. Only equation is given. Suppose any one of the equation ax plus by plus c is equals to 0 equation is given. In this case, slope m is equals to minus a by b. Here we have three formulas. Three slope formulas are there. One is m is equals to tan theta. And second one is y2 minus y1 by x2 minus x1. And third one is minus a by b. When use this first formula, if theta, suppose angle 30 degrees is given. If the inclination of the line is 30 degrees, in this case, the slope of the line m is equals to tan of theta. Use this formula, tan 30. Only 2 points are given, A, B, 2, 3, 3, 4. This type of points are given. In this case, slope m is equals to y2 minus y1 by x2 minus x1. Suppose any one of the equation 2x plus 3y plus 5 is equals to 0. In this case, slope m is equals to minus a by b. Here a means the coefficient of a, coefficient of x, b with the coefficient of y. Minus a by b means here the slope of this line is minus 2 by 3. Slope of this line is minus 2 by 3. These are the slope formulas. We have only 3 slope formulas are there. Okay. Next, applications of this slope. Suppose two lines are parallel. Parallel means these two lines, suppose this is x-axis, slope of the first line is m1 and the slope of the second line is m2. Here these two are parallel lines. When two lines are parallel, suppose these two slopes are equal. Suppose m1 is equals to m2. m1 is equals to m2 means these two are parallel lines. Two lines are parallel. That implies by implies condition is m1 is equals to m2. Two lines are perpendicular. In this case, first line slope is m1, second line slope is m2. Here these two are perpendicular. Perpendicular means product of their slopes is equals to -1. Okay, parallel lines condition is m1 is equals to m2. Perpendicular lines condition is m1 into m2 is equals to -1. When two lines are equal, when two slopes are equal, if two lines are parallel, in this case their slopes are equal. Product of their slopes is equals to -1. In this case the lines are perpendicular lines. Okay. Next, straight line. This is the general equation of the straight line. Ax plus by plus c is equals to 0 to the general equation of the straight line. Next, equation of the straight line in intercept form is, the general equation of the straight line is Ax plus By plus c is equals to 0. The equation of the straight line in slope intercept form is y is equals to mx plus c. Here c be the y-intercept value, m be the slope of the line. Next, equation of the straight line in slope point form. The equation of the straight line in slope point form is y minus y1 is equals to m into x minus x1. Next, equation of the straight line in 2 points form. 2 points form is y minus y1 is equals to y2 minus y1 by x2 minus x1 into x minus x1. Equation of the straight line in intercept form. Intercept form is x by a plus y by b is equals to 1. Here this line, this is the equation of the straight line in intercept form. This is the equation of the straight line in intercept form. Here this is x-axis and this is y-axis. This equation of this line is x by a plus y by b is equals to 1. Here x-intercept is small a, means here to here distance is small a, y-intercept is small b. So here to here distance is small b. This is origin O of 0, 0. Here OA distance is small a and OB distance is small b. Next, equation of the straight line in normal form. Equation of the straight line in normal form is x cos alpha plus y sin alpha is equals to p. Let us draw this diagram. This is this line x cos alpha plus y sin alpha is equals to p. This is x-axis and this one is the y-axis. Here we can draw one perpendicular line from origin to this line. Here origin to this line. Here this line is makes an angle alpha with positive direction of x-axis. Here I am taking, this is A point, this is B, and the distance from O to C is P. This is the P. Here the RHS value is P. So this distance O to C distance is P, and this angle is alpha. This is the equation of the straight line in normal form. Next, equation of the straight line in symmetric form. Symmetric form is x minus x1 by cos alpha is equals to cos theta is equals to y minus y1 by sin theta is equals to r. X minus x1 by cos theta is equals to y minus y1 by sin theta is equals to r. What is the equation of the straight line in symmetric form? X minus x1 by cos theta is equals to y minus y1 by sin theta is equals to r. Here, this theta be the inclination of the line, x1 comma y1 be the any point on the straight line. Sorry, given point on the straight line. Theta be the inclination of the line and this be the q point, q of x1 comma y1 point. X comma y. Here q be the coordinates of q are x1 comma y1 coordinates of q. This is the symmetric form of the straight line. Next, these are various forms of the straight lines. Next one is distances. Suppose capital A, coordinates of capital A, x1 comma y1, coordinates of capital B, x2 comma y2. The distance from capital A to B is formula AB is equals to under root of x2 minus x1 whole square plus y2 minus y1 whole square. This is distance between 2 points formula. And next one, suppose capital A of x1 comma y1 be any one of the point. The distance from capital A to the line ax plus by plus c is equals to 0. The perpendicular distance from capital A of x1 comma y1 to the line ax plus by plus c is equals to 0 is mod of ax1 plus by1 plus c by under root of a square plus b square. This is the perpendicular distance from capital A of x1 comma y1 to the line ax plus by plus c is equals to 0. Next one is the distance between two parallel lines. Suppose this is L1 is equal to 0, this is L2 equals to 0. These two are parallel lines. This first line equation is ax plus by plus c1 is equals to 0. And the second line equation is ax plus by plus c2 is equals to 0. In this case, how to find out the distance between these two lines? The distance between these two lines is formula mod c1 minus c2 by under root a square plus b square. Here x coefficients are same, y coefficients are same. Here I am taking only numerator value c1, c2. So this formula, the distance between these two parallel lines formula mod c1 minus c2 by under root a square plus b square. Next one is concurrent lines. Next, concurrent lines. Concurrent lines means two or more lines passing through the same point. Here the point is this. Suppose here this is the P point. Here we have three lines. These three lines are passing through same point, P point. So these three are called concurrent lines. These three are concurrent lines. Suppose the equations of these lines are ax are, here I am taking a1x plus b1y plus c1 is equals to 0. Second line equation is a2x plus b2y plus c2 equals to 0. And third line equation is a3x plus b3y plus c3 equals to 0. Here these three are concurrent. Concurrent means satisfies this condition. The condition is mod of a1, b1, c1, a2, b2, c2, a3, b3, c3 is equals to 0. Det of a1, b1, c1, a2, b2, c2, a3, b3, c3 is equals to 0 means here a1x plus b1y plus c1 and a2x plus b2y plus c2 equals 0, a3x plus b3y c3 equals 0. These three lines are concurrent lines. Next, centroid. Centroid means the point of intersection of medians. Any two medians of a triangle is called a centroid. The point of intersection of any two medians of a triangle. Medians means the line segment joining vertex to the midpoint of the opposite side. This is vertex A, vertex B, vertex C. Here I am taking the midpoints D, E, F. Centroid means the point of intersection of any two medians of a triangle. Median means the line segment joining vertex to the midpoint of the opposite side means here AE, and another median is BF, and here third median is CD. Here these three are concurrent. Here these three are the point of concurrency is here this point. This is denoted by G. So centroid of the triangle is denoted by capital G. Here the vertices of the triangle are x1 comma y1, x2 comma y2, and third vertex I am taking x3 comma y3. In this case, the centroid of this triangle is x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. This also can be written as a plus b plus c by 3. This is also can be written as a plus b plus c by 3. This is centroid. Next one is incenter. Incenter means the angular bisectors of the internal angles of a triangle. First, let us draw a figure. This is triangle A, B, C. The bisectors of the internal angles of a triangle means these lines. This is one of the line, then this is the other line, this is the third line. Here these three are concurrent. This is the point of concurrency. This is the incenter. The incenter is denoted by capital I. Incenter is denoted by capital I. In this triangle, small a be the side AB value, side BC side value is, here small a be the BC side value and small b be the AC side value, AC distance value, A to C distance, AB distance value is C. In this case, incenter of this triangle ABC is, and vertices are same. Vertex are same, x1 comma y1, x2 y2, x3 comma y3. In this case, incenter I is equals to small a x1 plus b x2 plus cx3 by a plus b plus c, comma, a y1 plus b y2 plus c y3 by a plus b plus c. This is the incenter of the triangle. Okay. Here one more formula is there, that is, suppose the vertices of a triangle are capital A, vertex of capital A is equals to, suppose 0 comma 0, vertex capital B or vertex capital O is equals to 0 comma 0. So here I am writing the vertices. Suppose one vertex O 0 comma 0, comma, second vertex capital A comma 0, third vertex capital B 0 comma B. In this case, the incenter of the triangle is capital I is equals to A into B by A plus B plus under root A square plus B square, comma, AB by A plus B plus under root of A square plus B square. When we use this formula, here one vertex must be a 0 comma 0 and remaining two vertices are in this form, A comma 0, 0 comma B. In this case, apply the incenter I is equals to AB by A plus B plus root A square plus B square, comma, AB by A plus B plus root of A square plus B square. Next one, orthocenter. Orthocenter means the point of intersection of attitudes of the triangle. This is the triangle. Attitude. Attitude means perpendicular from vertex to the opposite side. Suppose this is ABC triangle. The perpendicular from vertex to the opposite side. This is one of the attitude. This is another attitude. This is the third attitude. Here these three are attitudes. These three attitudes are concurrent here. This point is the point of concurrency. So this point is denoted by O. O be the orthocenter here. Orthocenter is denoted by O. The point of intersection of attitudes of the triangle is called orthocenter. Suppose the vertex capital A, suppose the vertex CRO 0 comma 0, vertex capital A, vertex capital A is A comma 0, vertex capital B is equals to 0 comma B. How can you find the attitude in this case? Here the orthocenter is, the formula is K into y2 minus y1, comma, minus k into x2 minus x1. This is the orthocenter, where k is equals to x1 x2 plus y1 y2 by x1 y2 minus x2 y1. This is the orthocenter formula. K into y2 minus y1, comma, minus k into x2 minus x1. Here k value is x1 x2 plus y1 y2 by x1 y2 minus x2 y1. Suppose the any one of the right angle triangle is given. In this case, how to find the orthocenter? Let us see. Suppose this is right angle triangle. A comma B comma C are three vertices. This triangle is right angle at A. In this case, the orthocenter is equals to the vertex of the right angle is the orthocenter. So, in this case, the orthocenter is capital A. Next one is circumcenter. Circumcenter means perpendicular bisectors of the sides of the triangle. Perpendicular bisectors of the sides of the triangle. Perpendicular bisectors means this is capital A, B, C triangle. Bisectors, perpendicular bisectors of the sides. Suppose this is perpendicular to BC and perpendicular bisector also. This is the perpendicular bisector of AB and this is the perpendicular bisector of the side AC. In this case, this is here these three also concurrent. Circumcenter is denoted by S. Here this A, B, C and S satisfies this condition. SA is equals to SB is equals to SA. Suppose capital A vertex is A comma 0, B vertex value 0 comma B and this is origin. I am taking the two vertices 0 comma 0. Suppose these three vertices are given. For example 0 comma 0, 1 comma 0, 0 comma 3. These type of vertices are given. In this case apply this formula. In this case the circumcenter of the triangle S is equals to formula y2p minus y1 cube by 2r comma minus of x2p minus x1 cube by 2r. Here p is equals to x1 square plus y1 square and q value x2 square plus y2 square. The denominator is capital R is there na? So capital R is equals to x1 y2 minus x2 y1. Here the vertices are in the form of 0 comma 0, A comma 0, 0 comma B. In this case circumcenter formula. S is equals to y2p minus y1q by 2r comma minus of x2p minus x1q by 2r. Where p is equals to x1 square plus y1 square, q value x2 square plus y2 square and capital R is equals to x1 by 2 minus x2 by 1. Okay, we will continue in the next class.